Welcome back to our how-to video series. So far, you've learned how to unbox and assemble your product, how to plan your mission and cue ground control, and you've completed a successful launch and recovery. So now all that's left is to pull the data from the drone so that you can use it for whatever surveying work you need to do. It's a very simple step. All you're going to do is just pull this USB right out of the drone and plug it right into the side of your computer. That's going to bring up an autoplay box and you'll be able to access the files you need in the processor. And in this next part of the video, we're going to cut to my screen and I'm going to walk you through exactly how to use our processing software and how to import it into Civil 3D.
So first things first, we're going to want to plug in our USB drive that came out of the drone, and then we'll open the file location. So we have SmartDrone D right here, and the flight I'm looking for is in 2021, and it's November 8th. So if we look down here, we got 21/11/08, and the time I need is 10:21. So you'll see it's this file right here. So we can take this file, and I'm going to copy it, and the fastest way to do this is to put it on your desktop, and it processes the file faster. So we're going to copy it over to our desktop really quick. And now we can open up our file here. Now you see your processor should already be down here. So you're just going to click on that. That's going to open up a window. Perfect. Now you're going to select your state plane, your zone. The one I'm going to be doing is in Texas North Central. And your geoid or ellipsoid if you're using that. You'll select your unit. We use survey feet. And you'll select, if you're doing infield, you just want the data off the drone, you can click infield. If you are using a local base station for increased accuracy, you're going to click that, and that's going to allow you to put in a RINEX file and your known location or Opus corrected location. Or you can use SmartBase, which is going to look through online databases and get you a more accurate result than your infield, but not as accurate as if you have your own local base. And we're also going to be using the CheckShot tool, so that we can get some additional information out of some rover points that we took to cross-check with the accuracy. So the first thing we're going to do is go through, populate these, we'll hit process. So that's going to open up our next window, which is our base station input. So we're going to find our RINEX file. Mine's right here, and that's a 21.0 file. I'm going to open that, and then we're going to put in our coordinates. So for mine, the coordinates are as follows. Alrighty, and then our vertical units are in feet here. So that's why we put in 6.56168 as opposed to 2 meters. Now we can upload our CheckShot file. So if you look here, we're going to be using this one. And then you're going to want to select whatever delimiter you need to get your result. Our IG9 outputs ones that need a comma. So for us, our first populated point is a shot number, and then we output easting, then northing, then we do our elevation, and then we have a label. Now yours may be different. It all depends on how your collector outputs its information. And then we just let the information process. So this window will stay up for a little while, about 15-20 minutes, and then you can come back and it'll be ready. And we see we pop up with this processing complete window. So we can just click OK on that. And you can close out of the command box that comes up as well. And then you'll notice all the files we're looking for are going to be right here in the finish folder. So as you can see, we have an accuracy report TXT file. We have a GNSS report PDF that's going to kind of decipher our RINEX and give us some cool graphs we can look at. And then you also have your ground points for the 1 foot, ground points for a 25-foot grid, and our process result. So what we can do now is we can take a look at this accuracy report, So what you see is we only really care about our, Z or elevation. So we have easting, northing, and then this is the Z survey, and this is Z the drone measured. So you see, like, we're within a tenth there, we're within a 500th there. Some really good data here. Now we can go take a look at our ground points, and we'll just go ahead and put it right into Civil 3D. So we can open up Civil 3D on our computer, and Imperial, of course, because we're using feet, but metric if you output in meters. This is a pretty simple process. Just let it boot up here. All right, here we go. So the first thing we're going to do is we're going to click and create a surface. So if we click here, So the first thing we're going to do is we're going to click and create a surface. So if we click here, create surface, and all these settings here are fine. And then we can click here and go to surface 1. By the plus symbol, we'll hit there, and by definition, we can hit there. And now we see point files. So we can right click here, click add, and then we'll just go find our file. So my file is under my desktop where we unpacked it. There it is right there. So I can go to finished, and we'll put the 25-foot grids in here because these other point files have a lot of data in them, and Civil 3D actually can't handle that. So we'll open that up. See, it goes in, and then you'll see it populates lots of points here. And all we have to do here is just hit OK. I'll give it a second, and then if I come over here to surface 1, I just click zoom to, and there we go. We got our fancy surface, and now you can do all of your different things you need to do through here, and it's as simple as that. Thanks for watching.